Hey kids, this is M to the R to the K to the Izzle, and this is video 20 where we are talking about story problems. Now, I've given you this note sheet, and I expect you to read it. I'm not going to read it to you, especially not here. I'm going to very quickly go through part of this note sheet and talk a little more in depth about other parts. So, one problem that students have is reading words and writing those as expressions. So here's some practice. I'm just going to very quickly go through these. 6 more than Jamie is J plus 6. The sum of Mike and Bill's cookies is M plus 7. The difference of X and Y is X minus Y. 6 less than Chad is C minus 6. 12 less than Maria is M minus 12. Now, the thing that you want to notice for these is that they're written in reverse from how you read them. Because 6 less than Chad, if you write 6 minus C, then what you are doing is taking 6 and subtracting whatever Chad has. That's not what this says here. What this says is take Chad and then take away 6, so C minus 6. Same thing for Maria. This is the reason why I wrote this one in reverse from how it read as well. It doesn't matter as much when you're adding, but I think it's a good habit to when you see something less than or something more than to write that as to write it backwards from how you read it, because while it doesn't matter when you're adding, it does when you are subtracting. The cost of M screws at 79 cents per screw. That's 0.79 times M. 6 times the number of cats is 6C. 1/3 A. 500 divided into M parts is 500 divided with M. 24 divided with B. Now these last three I could write as fractions. A over 3 is 1/3 of A. 500 over M. 24 over B. Okay, all of those work instead of division. And in fact, I tend to prefer to write things out as fractions because they're actually easier to solve. Now, a really tricky one is the phrase "as many as," because it frequently contains a whole equation, and it's frequently written in reverse from how you read it. So think about, there are 6 times as many cars as buses. How many are there more cars, or are there more buses? According to this, there are more cars. So the number of cars is 6 times the number of buses. So the equation is C equals 6 times B. If you notice, this is written very differently from how it's read. Okay, so take a stab at something like this. There are 5 more than 4 times as many cats as dogs. Are there more cats, or are there more dogs? There are more cats. So the cats is the number of dogs times 4 plus 5. Okay? So this is a tricky phrasing that you need to be able to handle. Further down, I have a bunch of examples. I will very quickly do the ones on the left. I want you to do the ones on the right. So 8 years ago, Clyde was 7 years old. So I take Clyde and I take away 8 years, and that should equal 7. That's option D. Okay? 4 times a number is equals. 9 more than the number, n plus 9. Guys, always find the equals. Todd's weight is 16 pounds more than 3 times his son's weight. So I take his son's weight times 3 plus 16, and that's Todd's weight. The quotient of P divided with R, that's going to be P over R, decreased by minus the product of P and R, P times R, is 5, equals 5. Okay? This next example has to do with value. So let's very quickly go through it. Jenna has $12.50 in pennies, dimes, and half dollars. She has 5 times as many dimes as half dollars. That's an equation. And she has 5 times as many pennies as dimes. So if she has H half dollars, let H be the half dollars. And let's write equations for how many dimes and pennies she has. Well, she has 5 times as many dimes as half dollars. That's the dimes is 5 times the half dollars. And then the pennies is 5 times the dimes, except that I want everything to be in H, so let's sub in what the dimes is worth, 5H. So that's 25H. So I have H half dollars, 5H dimes, and 25H pennies. Now, using those expressions, let's write an equation for the total value of all of her coins. This equation uses a pattern called total value. And here's the pattern. You take the quantity of something, how much you have of something, times the value of each of those things. And then you add that to the quantity of something else times the value of each of that thing, plus the quantity of something else times the value of each of that thing, etc., etc., and that equals the total value. So, half dollars. She has H half dollars, and they are worth 50 cents. Plus, she has 5H of the dimes, and that's worth 10 cents. Plus, she has 25H pennies, and that's worth 1 cent. So I take how much I have times what it's worth, and I do that for each thing that I have, and that equals total value, which is $12.50. This is the total value pattern. You see it a lot when we work with money. Okay? Now, more generally, solving a problem, there's a few things that you should do. First of all, read the whole thing. Don't try to solve it on the fly. Take a second, read it all, get it in your head. And if it's on a quiz, when you get the quiz, take a second and read those problems first, just to get them in your head. And then do the rest of the quiz, and then go back and read them again. Okay? And then identify what the problem is asking and write a let statement for that thing. Decide that some variable represents the thing that you have to find. And then write your equation and solve it. So in these examples, 3 times a number is 6 more than that same number. What is the number? The number is the thing that I need to find. So the number, let's let n be the number. Okay? 3 times a number is, there's my equal sign. 3 times a number is 6 more than that same number, n plus 6. There's my equation. Then I solve it from there. Minus n, I get 2n equals 6, and so n is 3. Okay, let's try one more. We will go a little bit over time, and I'm okay with that. The temperature today was 15 degrees more than 1/2 of yesterday's temperature. It is 40 degrees today. How warm is it yesterday? So let's let y equal yesterday. Okay. Now, there's a couple of pieces of information scattered around this problem. The temperature today is. Now, this is something that I don't know yet, and I don't have a variable for, so let's just leave it blank. Maybe we can write something in later. So blank is 15 degrees more than 1/2 of yesterday's temperature. So I take yesterday's temperature, and I want half of that plus 15. Okay, I could also write it as y over 2 plus 15. Either way works. Okay, now this blank is today's temperature. And it says later in the problem, oh, today it is 40 degrees. Okay? If you aren't sure what to write in a certain part of an equation, leave it blank and fill it in later, because maybe they give you some more information later on in the problem. Here's my equation. I would then solve it from here. Minus 15 minus 15, 25 equals y over 2 times 2 times 2. Yesterday it was 50 degrees. Okay? All right, I've gone over time, but I wanted to get all of this in your head. Tomorrow we will practice some more. Have a great day. See you later. Bye-bye.